Bismillahir Rahmanir Rahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum students. This is Hamza Noor, and today here I am another video lecture, and the topic is trigonometric identities and integration by using trigonometric identities. A-level mathematics 9709, pure mathematics 3, and the attempt is May June 2021, paper 3, variant 2, question number is 6. Part A is asking prove that cosec 2 theta minus cot 2 theta is equals to tan theta. Now, since you know the fact that in place of cosec theta, you can actually write 1 over sine theta. So we can say that in place of cosec 2 theta, we can write 1 over sine 2 theta. And in place of cot 2 theta, you can write 1 over tan 2 theta as well, but you can write cos 2 theta over sine 2 theta as well. Okay. Now, since sine 2 theta is a common denominator under both of these terms, these two terms. Now, this means that these two separate fractions can be expressed as one single fraction, which is 1 minus cos 2 theta divided by sine 2 theta. Now, basically, you have only one option to express sine 2 theta, which is 2 times sine theta times cos theta. But there are three ways to express cos 2 theta. The first one is cos square theta minus sine square theta. The second one is 2 cos square theta minus 1. And the third one is 1 minus 2 sine square theta. All of these identities are given to you in your formula sheet, but it's highly recommended that you must do enough past paper practice such that all of these identities are on your fingertips. So the question basically arises in mind that, which of the options to choose to express cos 2 theta in such a way that you don't waste your time in proving the identity and you actually prove the identity effectively and efficiently. So you have to compare it with your requirement. Since the requirement is tan theta, which can be expressed as sine theta over cos theta. So this means that if I leave this fraction in such a way that the numerator is completely expressed in sine theta, and I only have one option to express my denominator, which is 2 times sine theta times cos theta. So after the simplifications, I would be able to achieve sine theta over cos theta, which is actually tan theta. So you will express cos 2 theta as 1 minus 2 sine square theta. And in place of sine 2 theta, you will write 2 sine theta multiplied by cos theta. Now, since 1 and minus 1 are cancelled out, in the numerator you have 2 sine square theta. In the denominator you have 2 sine theta times cos theta. So this 2 and 2 is cancelled out. This sine theta is cancelled out and 1 sine theta is remaining. Therefore, you have expressed this whole fraction in the form of sine theta over cos theta, which is expressed as tan theta. As simple as that. Let's move on to the next part. Part B is saying that hence show that the integration of cosec 2 theta minus cot 2 theta with respect to theta and the limits are from pi over 3 till pi over 4. This is equals to half times ln2. Now hence basically means that you need to use the result of the earlier part. And since we know the fact that cosec 2 theta minus cot 2 theta can be expressed as tan theta, so the question is basically asking you to integrate tan theta with respect to theta, and the limits are from pi over 3 till pi over 4. But in the formula sheet, as you are given the integrations, the integrals, the standard integrals of sine theta, cos theta, you are not given a standard integral for tan theta. Okay, you need to actually integrate it by a procedure. So in place of tan theta, we can actually write sine theta over cos theta. And now basically, I can use the method of integration by recognition method. The upper limit is pi over 3. Sorry. Pi over 3 till pi over 4. Okay. So you need to integrate sine theta over cos theta with respect to theta. Now here you can apply the method of integration by recognizing the integral by recognition method. Since you know that if you leave your fraction in such a way, I mean, if the fraction is already given to you in the form of f dash x over fx, and if you integrate this with respect to x, you will get ln fx plus c. So this is basically the reverse process of differentiating ln fx. But if the fraction is not in this form and you have to just adjust a constant term, you have to have, if you have to just adjust a constant term in order to achieve this form, so you can actually adjust the constant terms and you can integrate it by this way. So in this case, I would say that f dash theta over f theta, if I leave my fraction in this form, so if I integrate it with respect to theta, I'll get ln f theta plus c, and in this case you have a definite integral, so no need to add a constant term. But the issue is that if you take the cos theta, basically the denominator of the fraction as f theta, so actually your derivative of f theta, which is f dash theta, this turns out to be minus sine theta. But in the original fraction, you are not seeing any minus sign over here. So this definitely means that you can adjust a negative sign. So, I mean, how to express this sine theta over cos theta in such a way that I can actually use this method. I can actually achieve the derivative of f theta over f theta, and then I can integrate it and simply write ln f theta. So this sine theta over cos theta can be expressed as, if we take the minus sign outside and then multiply it with minus sine theta over cos theta. So basically you have achieved the same thing, which is sine theta over cos theta itself. Okay, the upper limit is pi over 3 and the lower limit is pi over 4. Now you can actually use this procedure. Now your fraction is exactly in the form of f dash theta over f theta. The derivative of the denominator turns out to be exactly in the numerator. Okay, so this would be, since there is minus sign already over here, so minus ln cos theta, and the limits are basically from pi over 3 till pi over 4. No need to add, let's see, no need to add a constant term. Now this minus ln cos theta can be expressed as ln cos theta raised to the power minus 1, which can be expressed as ln 1 over cos theta, and eventually you can write ln sec theta as well. But we are not required to do so. We are just required to put the limits over here and prove this value, which is half ln2, which is supposed to be your final answer. So you don't need to actually express minus ln cos theta like ln sec theta. What you need to do is just apply the limits over here. So let me make some space on this page. So this is minus ln cos pi over 3 minus ln cos pi over 4. Cos pi over 4. All right. So this can be written like this: minus ln cos pi over 3 plus ln cos pi over 4. So just first find out the exact values of cos pi over 3 and cos pi over 4. And remember to keep your calculator in the radian mode. So cos pi over 3 is basically half. So this is minus ln 1 over 2 plus ln, what is the exact value of cos pi over 4? Under root 2 over 2. All right. So this is ln under root 2 over 2 minus ln half. Now you can actually use the quotient rule of logarithms. So ln and the term would be under root 2 over 2 divided by half. So what is basically under root 2 over 2 divided by half? This is under root 2. So ln under root 2 is achieved so far. Now, since you know the fact that under root 2 can be expressed as 2 raised to the power half, now you can actually apply the power law. This power can be multiplied over here as a constant term. So therefore, you have finally achieved your answer, which is half ln2.